Good day, everyone, and welcome to our special report. Today, we embark on a fascinating journey through time, exploring the timeline of computer evolution. From its humble beginnings to the sophisticated technology we rely on daily, we will uncover you the key milestones and groundbreaking innovations that have shaped our digital world. Join us as we trace the remarkable path of computing, revealing the ingenuity and vision that have driven this incredible transformation. Let's dive in and discover the story of how computers have revolutionized our lives. We will be talking about the first generation of computers from 1946 up to 1959. So, this era saw the emergence of massive machines that were groundbreaking for their time. And first up, we have the vacuum tube technology. The primary electronic components were vacuum tubes. Yes, and these glass bulbs facilitated switching and, of course, for amplifications. But they were large, fragile, and, of course, generated significant heat. And second one, we have the enormous size. Due to the enormous vacuum tubes, these computers were enormous, often filling the entire rooms, and it requires extensive infrastructure and cooling systems. Third one, we have the high power consumption. Operating thousands of vacuum tubes led to exceptionally high power consumptions and considerable heat output. And when it comes to manual programming, programming was laborious with instructions and data manually input using punch cards or paper tape. A stark contrast to today's user-friendly interfaces. And despite their limitations in size and their speed and reliability by modern standards, these first generation computers were revolutionary. They performed complex calculations at unprecedented speeds, laying the essential groundwork for the digital revolution, and of course, they are the true ancestors of every digital devices that we use today.
The second generation of computers emerged between approximately 1957 and 1963, marking a significant advancement in computing technology. This era is primarily defined by the replacement of bulky vacuum tubes with transistors as the main electronic component. There are key characteristics and innovation. The transition to transistors brought about several crucial improvements. First is the transistors. These were smaller, faster, more reliable, and consumed less power than vacuum tubes, leading to more compact and efficient computers. Next is size reduction. Computers became significantly smaller than their first generation predecessors. The third one is power and heat. They required less electricity and generated considerably less heat, though cooling systems were still necessary. Next is speed. Computation speeds increased dramatically with calculations performed in microseconds. And lastly was the cost. While still expensive, the cost of second generation computers was reduced compared to the first generation.
In the third generation of computers, 1965 to 1971, marked a big leap in technology because of the introduction of integrated circuits. Here's a clear overview. Technology used introduced integrated circuits, also called chips. Each integrated circuit combined multiple transistors, resistors, and capacitors into a single small package. This made computers smaller, faster, cheaper, and more reliable compared to transistor based second generation machines. Size and speed. Smaller in size, required less power, and produced less heat. Processing speed increased to nanoseconds, could handle could, could handle multi-programming, running several programs at the same time. Memory and storage. Magnetic core memory was common for internal storage. Magnetic tapes and magnetic disks were used for secondary storage, making data retrieval faster. Software and languages supported high-level programming languages such as COBOL, Fortran, BASIC, ALGOL, and Pascal. Operating systems became more advanced, enabling time sharing and multi-programming. Applications used in business, universities, research, and government offices. Widely adopted because they were more cost efficient than earlier generations. Example of third generation computers: IBM System 360 series, one of the most popular and influential mainframe computer families. Honeywell 6000 series, PDP-8 and PDP-11 by Digital Equipment Corporation. ICL 1900 series. So, there are advantages and disadvantages of third generation. More so the advantages: more reliable and smaller than second generation computers, faster performance and less energy consumption, easier to maintain and more affordable, supported multiple users and multitasking. So here are the disadvantages: still very expensive compared to personal computers today. Required air conditioning due to heat, though less than before. Complex to design compared to earlier generations. So, the third generation of computers revolutionized computing by introducing integrated circuits, which drastically improved speed, efficiency, and accessibility. This was the era when computers became practical for businesses, research, and education, setting the stage for the personal computers of the fourth generation.
Fourth generation of computers are typically defined as the era that began in the 1970s and continues through the present day. So its defining break from the third generation is the replacement of the multi-chip CPU designs with the single-chip microprocessor and the rapid adoption of very large-scale integration (VLSI), in which it packs thousands to millions of transistors into one chip. And this made computers smaller, cheaper, and far more powerful per dollar than earlier machines. So how does it change? So the microprocessor moved the CPU's functions, mainly the ALU, the control unit, and the registers, onto a single integrated circuit that produced a smaller motherboards, lower power, lower manufacturing costs, and faster clock rates as fabrication improved. On the other hand, the VSLI, or the very large scale integration, enabled packing many or thousands or millions of transistors on a chip, which expanded the cache or cache, increased instruction complexity, and allowed specialized coprocessors and integrated peripherals. This results to a dramatic increases in performance per watt and the cost efficiency, which made personal, portable, and embedded computers feasible. So the impacts of the fourth generation socially and economically starts with the democratization of computing, in which small businesses, schools, and households could afford computers. Computing moved from large institutions to individuals. Then the industry shift. So the rise of consumer hardware companies like Apple, IBM's PC ecosystem, and the Commodore software industry, and it offers new career path. And lastly is the education and the culture sector, in which in today's generation, computer literacy become essential in video games and home productivity software become mainstream.
Now, turning our attention to the fifth generation of computers, which began in 1980 and continues to evolve today. We observe a profound technological shift primarily driven by ultra-scale integration or ULSI and the burgeoning field of artificial intelligence. ULSI technology allows for the creation of incredibly dense and powerful circuits, enabling devices to become smaller, more energy efficient, and yet for more capable than their predecessors. However, it's the seamless integration of AI that truly defines this era, empowering computers to learn, reason, adapt, and interact with humans in increasingly sophisticated and intuitive way. This convergence has not only resulted in highly intuitive user interfaces and richer, more immersive multimedia experiences, but has also spurred the development of portable, powerful, and increasingly affordable machines, which often leverage advanced multiprocessor systems to handle complex computational tasks with remarkable speed and efficiency. As AI continues to advance, the fifth generation promises even more revolutionary changes in how we live, work, and interact with the world around us.